Hello everyone, welcome back to my YouTube channel, General Technology Knowledge. Today I would like to show and share about how to use SIMATIC Manager and WinCC Flexible to configure the analog input module. The first one is analog input module 33107K F02 0AB0. It is the analog input that we can select use for PT-100 or thermocouple or current 2Y, 4Y and also volt DC for input. And here is the analog input, also model 7P F01 0AB0. It is the analog input for only PT-100 type. Yes. So there are 8 channels in this module for PT-100. So we can connect directly of PT-100 to this module and it will show. Yes. And for this selection, I will detail for how to connect the PT-100 or thermocouple 2Y that convert from the thermocouple signal and then 2Y connect with this module. Okay. So I will detail all for this section. And we will connect with the HMI also. Yes. To show the actual value of PT-100 and TC on the HMI. Okay. So first, let me explain a little bit about how to select send for this module. Because right now I will use input type for all selection from A, B, C and D selection. Okay. So let me explain about how to select the hardware. So for channel number 0 and number 1, I will select to A. Yes. A, it means that we can use the 800, 250, 500 and 1000 millivolt. Yes. Or PT-100 or TC for this channel. Okay. When we selection to A. And for B, we can use 2.5 volt, 5 volt, 1 to 5 volt or 10 volt DC. Okay. So I will select to B for channel number 2 and number 3. And for channel number 4 and number 5, I will select to C. And then we can use the 4Y current. Yeah. 4 to 20 milliamp for Y. And for the channel number 6 and number 7, I will select with D. D it means that 2 Ys, the same as my slide that I already show. Here is the 2Y transmitter. So I connect the thermocouple plus and minus to here. And then when we select 2Y selection of the hardware, it will generate 24 voltage for us. Okay. Here is the 24 voltage plus and here is the 24 voltage minus. Okay. So we will got the supply to the temperature transmitter for 24 voltage. Okay. From this terminal. Then if the thermocouple generate the got the hotter for heater, it will connect to here, and then transmitter will generate 4 to 20 milliamp to the analog module. Okay, so this is just summary about how to select. Yes, I will select with 4 options, A, B, C and D. Okay, so that's all for this module. We can select 4 options. Okay, and let's go to how to wiring for module for PT-100 and this module also. I will summarize only one page for easy to understand. Okay, so let's go to check together. Okay, here is the detailed drawing of these 2 modules of analog input. The first one is analog input that we select with the 2-wire transmitter here. So I will use terminal number 16 series with the milliamp meter 4 to 20 milliamp. Yes, connect with the terminal number 16 and number 17. I will connect directly to the temperature transmitter 2 wires, because when we select to the 2-wire option for hardware, it will generate 24 voltage here. Yes, to supply the transmitter, and then I will use the TC connect from the sensor to be this terminal. Yes, of transmitter. And then for the PT-100 we connect like this. Yes, and this is a connection for 0 to 10 volt DC, and here is the current for 4 wires. Sorry, this is a 4-wire, not 2-wire. This is a 2-wire connection. Okay, I will correct this one. This one should be 4-wire. I'm also sorry, this confused. And here is the module of PT-100 8 channels. Yes, so we can use for connection 24 voltage for supply number 21st terminal, and then 40 for minus, and 21st terminal with the plus. Okay, and here is the connection all channel of PT-100. The first one, we can jump connection terminal number 3 and number 5, number 4 and number 6, and then the sensor will connect to the number 3 and number 4. Okay, so we can connect like this for all channel of PT-100. Okay, and for the address, it will generate when I show on the software SIMATIC Manager. Okay, so this is a summary of these 2 modules, and please this is a 4-wire, yeah, not 2-wire. Okay, so let's go to see the SIMATIC Manager to config. Yes, okay, so first I will create a new folder for PT-100 or TC testing. Okay, and then I will use SIMATIC Manager and WinCC Flexible to create the new project and simulation the touch panel. And the next video I will download to the actual panel. Okay, so first let's open SIMATIC Manager. Okay, and then I will create a new project. The project name is TC PT-100. Yes. Browse to find the folder that we already created on desktop. Here. And then click OK. So first we need to create the new station of SIMATIC S7-300. Example TC PT-100. Okay. Then let's go to click to hardware configuration, and then we can insert the rack. Yes, for this project we decide to be like this, and then go to SM. Yeah, go to insert the CPU. So right now I will use CPU 314C2PN/DP, the same as the existing video, and here is the IP address. And then let's go to add the two more module of analog. The first one is the analog this module. Yes, here 7K F02, right? So let's go to SM300 AI, and then go to scroll to find the module that match with our hardware. Yes, 7K F02. Drag and drop to the rack. Okay, and then we need to selection to be the same as the hardware configuration, right? Okay, let me show the same as here. Yes, here we need to follow up with here. The first one is A, so PT-100 or TC, right? Okay, so we can go to double click and then go to the input type. So we can select RTD, and normally I use the PT-100 standard. Yeah. And for channel number 2, we select to B, right? So B is 0 to 10 volt. It is correct. Yes. So no need to select. And for channel number 4 and number 5, I will use 2C, right? Select 2C. This one. C it means that 4Y current. Yes. So for Y current, I will select to 4DMU. Yeah, for Y current, and start from 4 to 20 milliamp. And for channel number 6 and number 7, I will use 2Y. So I will select 2DMU, 2Y here, current 2Y, and then 4 to 20 milliamp also. Okay. So that's all for configuration. We must follow up the selection to be the same hardware that I already explained here. Otherwise, when we download the software configuration to the hardware configuration, it will show SF. It means that fault, system fault. Yeah. So we make sure to select the software to be the same as the hardware. Okay. Otherwise, we cannot download, or it will got SF. Okay, system fault. So that okay, and then we will add one more module for PT-100 module A channel, right? 7PF01. Okay, so let me check 7P, right? 7P PT-100 here 0 It is 01. Yeah, it is correct. Yes. And here we need to selection also, but we have only software selection. For hardware we don't have. Yes. So for input we can select here the PT-100 type. Actually I always use 3Y. Yes. And the PT-100 type is standard. Yes. Here. And for other channel we can selection the same as this channel. Yes. Okay, standard. Okay, and then we can click OK, and then save the project, compile, and then download, right? So before download we need to connect the LAN cable from our PC to the Profinet part of PLC, right? And don't forget put the manual of our computer. Yes, like this. Example 253. Yes, put like this and then click OK. So we can ping to test. So cmd and then ping 192.168.0.1, right, for our CPU of PLC. So it's so like this, it means that we can communication between our PC to the PLC, right? So we can download. Okay. Run the CPU. Yeah. So right now I will show we don't got the SF. It means that no system fault here. It means that hardware configuration and software configuration is correct. Okay. So let's see here we don't got the SF fault. Yes. So it means that hardware configuration that we select and software configuration that we download correct and can use properly. Okay. So then the next step we will create the logic or scale to show, right? Okay. So let's go to our block. Open OB1 and then I will use ladder. Okay. So first I will use the PT-100 to show, right, for this channel. So start from PLC 256. Okay. So for this channel we can also online here to check. Follow our address. So PLC 256. Yes. And we can online monitor. Right now the temperature show around 26.3, right? Okay. So we can get the. So first we need to convert from double integer to double integer, right? We use this one. And then convert to real, right? So di to real, double integer to real, and then divide real, right? Divide by 10.0, right? The same as the previous video for PT-100 channel 1 or sensor 1. Okay. Then here is the starting address. Yeah, here PIW256. Yeah, PIW256 here. Okay. So we will put PIW256, and then we can command edit symbol with PT-100 or sensor 1. Okay. And here we need to create the temporary variables, right? Let's go to temp, and I will use the temporary, yeah, example temp1. It is the double integer, right? So dint. So temp1 here, and we can copy and then paste here. And we need to create one more for real data type, right? Okay. So temp2, it is the real, right? So real. Then we can put temp2, copy and then paste here, and we will show on the HMI, right? So we can use MD 0. Okay. And then we can save and then download to the CPU, and then we can online. Okay. So we will got around 25.6 degrees Celsius, right, for sensor number 1. Okay. So we need to create one more channel, yeah, for 4Y, right? 4Y transmitter, or we can use the standard source, loop control, or loop testing to use, right? So here we can use the insert the network, example channel number 4, right? This one. Channel number 3. Yeah, channel number 3, we need to use the example sensor sensor 2 signal 4 to 20 milliamp. Then we can use the FC105, right? That I already explained and tested in the previous video. So we need to convert, right? FC, right? FC105 here. Okay. Then here is the input, right? So input channel number let's go to our drawing. Yes, this input for channel number 3, right? It is the 4Y. Yes. So for Y we can use the address. So PIW256, PIW 260, 262, and this is 264, right? 264. So PIW 264. Yes, 264. Right now 20 milliamp. Yeah, I decrease to 4 milliamp. Okay, and then we will got like this. So we can use PIW 264, right? For channel number 3, PIW 264. And then we can use the converter. Edit the symbol. Yes, sensor 2, signal 4 to 20 milliamp, 4Y. Okay, like this. So we can change the symbol to be an integer. Yes. Example, sensor 2, signal 4 to 20 milliamp. Yes. And here is the high scale and here is the low scale. Example, I use 100 for high scale, and here is 0 to 0 for low scale. And for the bipolar, we can use address. Example, M 100.0. Okay, and here is the value. Example, MW 20. And here is the output, right? So example, MD 4. Yes. So we will got the signal like this, and then we can download. Okay. So right now around 0 degrees Celsius. If I adjust, I will test to 20 milliamp. It will show around 100 degrees Celsius. Okay. Let me decrease to 4 milliamp. Okay, we will got 0.05 degrees Celsius. Okay, so that's all for module number 2, and then we will use the module number 3, right, for this one. Okay, for 2 wise selection. So this is a thermocouple, so we can use the same as this one. So let's create for sensor number 3. Sensor number 3 connect with temperature transmitter 2Y. Yes, this one 4Y, and this one 2Ys. So we can use the converter from integer to double integer. Yeah, this one. And then convert from double integer to real, right? So di to real. And then divide by 10 also, right? Divide real. Okay, divide by 10.0. And here is the address. For address, we will start from PIW 266, right? Sorry, 260. this is the last one, right? 264, 66 and 68. Okay, so right now the temperature so around around 6.6 milliamp. So this one we cannot do this function. We can use also the same, because we use 2 for 220 milliamp also, right? So we will use the FC105 to convert this one. Okay, so this one should be PIW 268, yes, 268, and the data type should be integer also. So integer command sensor 3 4y start from 4 to 20 milliamp also, right? Okay, and this is a rank example. I use 0 to 100 degrees Celsius also, 0 to dot 0 M 100.1 MW 30 MD 8, right? Okay, then we can save and then download. Okay, so right now around 16 degrees Celsius, but the scaling around 150. Yes, let me change the scale. This scale we put the same as the temperature transmitter that's set on the setting of transmitter, right? To be the same, otherwise it should not the same with the actual temperature. Okay, so in this scale we need to put the same as the scale that we setting on the temperature transmitter twice. Okay, so for module number 1, yes, module number 1 here we already created. So for module number 2, I just connect only channel number 1, yeah, of PT-100. So let's create, go offline, and then insert one more network for signal from module 2 of PT-100 sensor channel number 1. Okay, so for PT-100 we can use the same as this one, yeah. So convert from integer to double integer, convert from double integer to real, and divide by 10, yes, divide real. And then for the address we can check on hardware configuration, start from PIW 272, right? So PIW272. Okay, right now around 25 degrees Celsius. Yeah. Okay, so this one should be divided by 10.0, and this one should be the address PIW272. Okay, PIW272. Okay, and this one we need to create the temp, right? Okay, example temp 3. The data type is double integer. So temp3 also, yes, and one more for real. So temp4, it is the real, right? So this one temp4, and I will use the MD12. Yes. So we can save the project and then download to the CPU. Okay, we will got the actual temperature around 25.4 degrees Celsius. Okay. So for part 1, I would like to explain about like this first. And for part 2, I will convert this one to show on the HMI. And then we can download the real project to the real HMI to show the value. Okay. So I would like to summarize for this section. So first we need to selection to be the hardware of the module, yeah, especially for module number 1, yeah, here we need to selection the hardware to be the same as the software that we already config, yes, here. Otherwise, if we download to the module, it will show system fault. If we select the incorrect function here. Okay, so it's very important. And for the option that we use to convert, we have two options. The first one, use with PT-100 directly. We can use convert from integer to double integer, and from double integer to real, and divide by 10. We will got the actual temperature. Okay. Example, I will hit the channel number 1. Yes, let me hit channel number 1. Yes. Let's see, the temperature is the increase. Yeah. 47. Yes. And for channel number 2, I will hit also. Yes. Channel number 2. So if I hit, yes, it will up also, right? Start increase. Temperature start increase. Here. And for channel number 4, right? The new model of analog, I will hit also. Let's see. Okay, 27, 29. I will hit more. 47, right? Start increase. And for this one, for example, for Y, yeah, I will select, yeah, to 20 milliamp, so it will show 100 degrees Celsius. Okay, so thank you very much for watching my video, and if everyone have any question, please kindly drop comment under my video. I will reply soon. And I would like to request all of you to like, share, and subscribe my video also, to get more notification and more new videos that I will create step by step. So in this time, I would like to say thank you very much, and in the part 2 we will see you again. Okay, thank you very much again, and see you next videos. Bye bye.